Alright, in this video we're going to discuss how to create a stem leaf plot and then how to comment on the shape of the distribution using that stem leaf plot. So this first example, I have data that I have basically a place to the left of a digit and a place to the right of the digit. So what we'll do is we'll use the left as our stem and then all the numbers to the right as our leaf. So that's the stem leaf. Okay, I think a good first step is always to organize your data from smallest to largest. So let's do that first. Let's sort our data. So as I write my numbers, I'm going to cross them out. So first I have 0.5. Alright, so sorting data may be tedious, but I feel it's worth it. It makes making our stem leaf plot all the faster. So when we're creating our stem leaf, we're going to draw a line, and these numbers over here are called the stem, and these numbers over here are called the leaf. So like I said, let's use the digit to the right of our decimal as the stem. Now this first number, it doesn't have a digit to the right, so it's 0 there, right? 0.5 is the same thing as 0.5. So we have 0. What we want to do is we want to look at the smallest digit, and then we want to look at our biggest digit. And it doesn't matter if all the digits are included. In this one we do, because we have 0, 1, 2, 3, 4, and 5. But regardless, we're going to include all the digits between 0 and 5. Okay, so even if one leaf is empty, you always include it on the stem. All right, so we have 0, 1, 2, 3, 4, and 5. Okay, and then I have another example where I'll show you that case where you have one that's missing. Okay, but you have all the numbers basically between the min and the max on your stem. Then for the leaf, we're going to fill it in. So starting with this 0.5, that's going to go on the other side of the 0. So that one goes away. Then we have 1.2, so 1. So view this as like a point basically. So 1.2. Cross that out. Now 2, what's on the left of a decimal? So it's 0.0. 2 is 2.0. 3.1. Okay. 3.2. Now it's really important that the order of your items on the leaf, they need to be in order. So that's why sorting your data kind of helps you do that automatically. Okay. 4.1. 5. 4.5 and 4.8. 5.4, 5, and 7. Okay. All right, great. So this is my stem leaf plot. So now let's comment on the shape of this distribution. So the shape is basically this guy. Okay. So what I've done is I've kind of curved over the shape of this, and what you want to do is you want to kind of like turn your head sideways, and you can see that this is like the same as this. Okay, so turn your head sideways to kind of like bring this down, right? Okay, when you turn it sideways, you'll see it looks like this. All right, the reason why it's nice to kind of look at it sideways on the horizontal, so like imagine turning this line here and then bringing it down to the horizontal, is because now we can see left and right skewed really nice. Okay, so if you have a heavy tail over here to the left, then this is a left skewed distribution. Okay, so you see how you have a heavier tail for the small numbers. So these small numbers are making this heavy small tail, and that's called a left skewed distribution. All right. If you had a distribution that looked like this, where you had large numbers out to the right, this would be a right skewed distribution. Okay. If you had, obviously, this is symmetric. Okay, so that's nice and symmetric. And then another option you'll often see is like a bimodal. right? Basically, you'll see an increase somewhere, and then it will decrease, and then it'll go down again. That's called bimodal. Okay, you can see all of that in your stem leaf plot. And that's really what the stem leaf plot tells you. It gives you a really quick way to view the shape of a distribution. All right, let's do one more example. So I have another data set here. So this data doesn't have decimals, but we have basically 2 digits, right? So the items on the first digit is going to be the stem, and the second digit is going to be our leaf. All right, like I said, first thing I like to do is always order my data. I feel like it really helps. So let's go ahead and do that first. Let's order it. Starting with the smallest number, it looks like I have 7, then 8, all right, so now that you have your data nice and ordered, let's look at our smallest number and our largest number. So in the stem, we need to account for all of the, if I said the stem is going to be the left digit, right? So we have a 2-digit number, then the stem needs to be all those left digits. Now notice this, for the smallest number, doesn't have a left digit, but 7 is the same thing as 0, 7, right? So this will start at 0, okay? Then we'll go all the way to 6. So 0, 1, 2, 3, 4, 5, 6. Now I know we don't have any 40s or 50s, but that's okay because and the stem should have a basically a number for every tens digit. Okay, so we'll go ahead and just leave those blank as we're going. So starting with 0, what do we have for 0? We have 0, 7, 8, 9. So 0, 7, 8, 9. Then we go to the next, we have 10. So 10 will be next to the 1, right? 1, 0, 10. 1, 3, 13. 1, 4, 14. 1, 5, 15. 1, 8, 18. Then we go to 20. Okay? 2, 0, 20. 2, 2, 22. 2, 3, 23. 2, 5, 25. And then next one we go to 30. Okay, 30. 3, 0, 30. All right, nothing in 40 and 50. We don't write zeros there, okay? There's just nothing there, but we do need them to be here, okay, in your stem. So just leave it blank. Then go to 60. Okay, and we have a 0 for 60. All right, so now let's comment on the shape of this distribution. So what do we have? Okay, now turn your head sideways and imagine putting that down on the x-axis, okay? So if I have the x-axis here, what does this look like? Okay, so there's small numbers down here, large numbers up here, right? So what do we have? What type of skew is this? Right, that's right. Skewed to the right, right? Because there's large numbers over here to the right. These large numbers to the right. So this is a skewed right distribution. All right, so now let's just go and do one more example. So I have data here that's now, all of my data is 4 digits. It goes from 1920 to 1946, and this data is already sorted. So I can skip that first step of sorting the data. So when I go ahead and start doing my stem leaf plot, since we have 4 digits here, and we're going from 1920 to 1946, what we're going to do is we're going to start with 192, and then we want to count all the way till we get to 194. So 192, 193, 194. So you see how I didn't skip any numbers as I was counting for my stem, okay? And of course we're going to need all of these because we have 120 all the way to 30 and then 40. So we'll need all 3, but regardless of if we needed all 3, we would have counted from 2 to 4, right? Okay, so now let's go ahead and fill in our, so that's our stem, so let's fill in our leaf. So starting with 1920, that's our first number. 192, oh, another 0, so we have to include both of those, okay. 1925, okay. 1931, so 1931, 1932, 1935. Okay. 1945. So that's 1945. Good. 1945. Okay. And 1946. 1946. Okay. So this is my stem leaf plot. Now, what does this look like? What does this distribution look like? They're all exactly the same, right? So this type of distribution where you have basically something that looks like this, this is a uniform distribution. Uniform distribution because it's uniform for all the different values of your data. Okay, so this is a uniform distribution. Okay, and of course you can also say that this is a symmetric distribution because all uniform distributions are also symmetric in that you can imagine you can fold it in half and it would lie on top of each other. So it's a symmetric uniform distribution. All uniform distributions are symmetric. Not all symmetric distributions are necessarily uniform.